Hello and welcome to our group presentation where we will be discussing thalidomide. My name is Brianna and I will first be talking about the history surrounding this drug. So thalidomide was first developed in the 1950s by a West German pharmaceutical company called Chemie Grunenthal GmbH. And it was first marketed as a sedative or tranquilizer, but soon it was used for treating many conditions such as the cold, the flu, nausea, and morning sickness in pregnant women. Thalidomide was licensed in July of 1956 for over-the-counter sale in Germany, and soon 14 other pharmaceutical companies were marketing thalidomide in 46 countries under at least 37 different trade names. In Canada, for example, the William S. Merrill Company marketed the drug under the name Kevadon on the Canadian market, and in the UK, thalidomide was produced by the Distillers Company under the brand name Distable. So these drugs were heavily marketed towards pregnant women. Advertisements from the Distillers Company claim that Distable can be given with complete safety to pregnant women and nursing mothers without adverse effect on mother or child. Many of these advertisements claim that thalidomide was safe for infants and pregnant women despite there being no evidence to prove the safety of the drug. The studies published by Chemie Grunenthal were not rigorous enough. For example, researchers were not able to obtain an LD50 level, and the drug was not analyzed for any potentially dangerous teratogenic effects. Also, the animal tests did not include tests looking at the effect of the drug during pregnancy. So following its widespread use in Japan, Australia, and Europe, practitioners began to notice links between mothers who had taken thalidomide and the presence of congenital mutations in their children. And it took 5 years for the connections to be made because the drug was traded under so many different names in 49 countries. And it was later found that the impact on development was linked to when the drugs were taken during pregnancy, and effects only occurred between 20 and 37 days after conception. The drug was formally withdrawn by Chemie Grunenthal in November of 1961 and by UK distributors in December of 1961. It is estimated that over 10,000 babies were affected by the drug worldwide, and around half died within months of being born. And a range of abnormalities was noted across the cases of patients, including phocomelia, which is a birth defect that can affect the upper and or lower limbs, disfigurements of the ear, ocular abnormalities, facial palsies, internal organ damage, and congenital heart disease. So thalidomide changed the way governments and medical authorities controlled their pharmaceutical licensing policies. For example, drugs intended for human use could no longer be approved purely based on the basis of animal testing. And in 1963, the UK set up the Committee on the Safety of Drugs to regulate that drugs are tested for potential toxic effects on a fetus. And in 1968, the Medicine Act passed, which made distinctions between prescription drugs, drugs only available in pharmacies, and drugs available for general sale. In the US, the FDA started requiring applicants to prove efficacy and to disclose all side effects encountered in testing. The thalidomide crisis also influenced the FDA's creation of pregnancy categories, which is a ranking of drugs based on their effects on reproduction and pregnancy.
Hi guys, I'm Constance and I'll be talking to you about the chemical structure and mechanism of thalidomide. So this is thalidomide right here. As you can see, the chemical structure of the top molecule and the bottom molecule are very similar. They both have the chemical formula C13H10N2O4. So the molecule thalidomide has two enantiomers. An enantiomer is a type of stereoisomer that is identical, except that there's a pair of molecules that are mirror images of each other and cannot be superimposed. So what does this mean exactly? So as you can see, the only difference is this bond right here. This one is solid while this one is dashed. So what do these mean? Well, the solid one means that it's coming out of the page, and the dashed one means it's going into the page. And so no matter how many times you turn it or twist it, they'll never be exactly the same because they're mirror images. So what exactly does this mean for the chemistry of it? Well, the R enantiomer has calming effects, which, as we discussed before, were used for morning sickness. And these calming effects are caused by this top molecule. So the bottom one, which is the S enantiomer, well, that is the one that causes the birth defects. And so this molecule is what we call racemic, which means that it exists in equal amounts of the R enantiomer and equal amounts of the S enantiomer. Because of this, it's hard to just isolate one of them, because there always will be flipping for it to reach this equilibrium of 50% of each. So you can't just isolate the calming effects and just isolate the R, because even if you do, at any point, the structure could just flip, and it cannot be administered just alone as it is. So let's talk about the mechanism. How is thalidomide formed? Well, this molecule, the way that the drug is synthesized is by reacting anhydride phthalic and 1L-glutamic acid together in order to form N-thiol-D-L-glutamic acid 4. So this is then reacted with acetate or ammonium acetate and a diphenyl ether and cyclized to form the final product. And this final product is going to be produced in a very high yield. So that means that it's very easy and favoring the final product of the reaction. So how exactly does this molecule affect our body? Well, it's a trick question. We don't know. So the way that the drug affects our body is not fully understood even today. So we have a lot of research done on this molecule, but the research just suggests a lot of things. So from this, we can assume some things about the mechanism of action. So the mechanism of action begins by the molecule binding to the cerebron to break down the transcription factors. It's used to block many of the signaling pathways, which lead to stopping the growth of blood vessels.
Hi, my name is Yalda, and I'm going to be talking about the biological basis behind thalidomide-induced teratogenesis. So when we're talking about prenatal development in the context of thalidomide, a key time period that we really want to focus on during the duration of pregnancy is around the 4 to 8 week time period. This time period is key in terms of the development of some very important features of the fetus, including limb buds, which start to be developed around week 4 and are typically fully formed by week 8, as well as other major features of the body, including the heart and the division of the chambers of the heart via septa, which divides the atrium from the two atria from each other, the two ventricles from each other, and the atria from the ventricles, as well as the development of key facial nerves and a whole bunch of other things. Now, in terms of limb bud development, which is one of the factors in terms of thalidomide-induced birth defects that is the most quote-unquote iconic, it involves two very important transcription factors called TBX5 and TBX4. Now, TBX5 is a transcription factor that essentially designates which cells of the fetus are going to turn into the forelimbs, which includes the arms, the hands, and the fingers on the hands. And then TBX4 designates the cells that are going to turn into the hind limbs, which are the legs, the feet, and the toes. Now, in the context of thalidomide, again, this 4 to 8 week time period is very crucial because, as we learned earlier, historically, thalidomide was often recommended as a treatment for pregnant women who are dealing with some pretty severe morning sickness. And again, historically, morning sickness has been known to be the most severe during this 4 to 8 week time period, which is important when we look at the birth defects that we saw in the babies that were born during the thalidomide epidemic. And again, because key limb development occurs during weeks 4 to 8, the earlier in the pregnancy that the pregnant woman had taken the thalidomide, the more severe the birth defects we saw in the children that were born. Typically, knowing the way that limbs develop in a fetus, we don't usually see babies who were born with fully formed legs with non-fully formed arms, although that was not always the case, as you can see with the picture of the little girl to the right. But one thing that we never ever see is there was never a baby that was born with fully formed distal appendages, aka the hand, the fingers, the feet, and the toes, without also having a fully formed upper appendage, the arm, the upper arm, and the forearm, because of the way that the limbs develop in the developing fetus. The specific mechanism of which the thalidomide induces teratogenesis is still not that well known. But what is known is that we know that it specifically targets a wide range of gene transcription factors and results in their complete degradation. One of the ones that I want to focus on is SAL4, which is a protein/transcription factor that is known to play a key role in the development of a wide variety of neonatal features, including, like I discussed earlier, the limbs, the nerves, especially those that innervate the face, the eyes, the ears, things like that. Again, the development of the heart anatomy, which is another birth defect that we see in babies that were born during this time period. Hematogenesis, the formation of blood cells, stem cell formation, and a much more variety of them as well. And again, thalidomide degrades SAL4 to the point of its complete absence in cells, which is why we see some very severe birth defects in the children that were born during this time period. This image I provided here from the article written by Matslieska et al. In 2018 shows when they treated fetal rabbits, because SAL4 is a transcription factor that is found across all mammalian species. And in image A, you see day 12 post-gestation of an untreated fetal rabbit, and the limb bud you can see is forming pretty well, whereas in B, you see the rabbit that was treated with thalidomide, and you can see that the limb bud is already in an early stage of degradation. And in fact, the entire fetus is not anywhere near as developed as the one on the left.
Here are some facts about thalidomide. Fewer than 3,000 newborns still exist today, despite the fact that it is widely assumed that the medicine may have harmed up to 100,000 babies in total. It reduced flexibility and mobility, for example, the ability to reach, stretch, and bend, which is difficult for daily tasks. And it also damage to the nerves in the fingers and toes causes pain, tingling, and numbness. The blood clots in the legs or near the lungs, drowsiness, and rash. It also have effects on mental and emotional health, such as depression, anxiety, and insomnia. Dr. Francis took a courageous stand against shady research and corporate pressure in 1960. During her first month at the Food and Drug Administration, when she refused to permit the distribution of thalidomide in the United States. In Germany and Great Britain, the drug has been prescribed as a sleeping aid, but it was subsequently determined that it has caused thousands of birth deformities. It can also use for treatment in myeloma. It is an oral immunomodulatory drug, has the capacity to modify or regulate the immune system. The antiogenic and immunomodulatory properties of thalidomide, according to clinical studies, is one of the most effective drugs for treating multiple myeloma. These studies show that it reduces monoclonal proteins by at least 15 in at least 30% of patients with relapse or refractory multiple myeloma. The use of its conjugation with the steroidexamethasone to treat myeloma obtained formal approval in 2006. And here's our references page.